welcome to this video. If you are new to this channel, I strongly encourage you to subscribe, and for those who are not first timers, you've been coming regularly, thank you for coming back again. In this video, we'll be looking at the 28th in the series, which is two sum of the Shem-Prashad lead code series, which we've been going through. The link to the Shem-Prashad series is in the description. So let's get to it. The two-sum algorithm. It says that given an array of integers nums and an integer value target, we are to return indices of the two numbers such that they add up to target. And we are told that you may assume that each input would have exactly one solution, and you may not use the same element twice. So you can return the answer in any order. So it doesn't matter which index you return before the other. Okay. So we have, for example, 2, 7, 11, and 15. And the answer, the target is 9. So 2 plus 7 definitely is what give us 9. And the indexes of 2 and 7 are 0 and 1. Same thing with this, 3, 2, 4. The target is 6. So we are told here that you may not use the same element twice, so we cannot say 3 plus 3 to give us 6, no. But we can do 2 and 4 because they are two different numbers, or indexes rather. So that is index 1 and 2. Yeah, 3 is the same number, but they are different indexes. This is index 0 and index 1, so they can sum up to give us target 6, and that's it. We are told that the minimum value, number of values will be 2, and up to 10,000. This is the range of the values and the target. So the target can be negative basically. So okay, and only one valid answer exists. So we are guaranteed that there's only one valid answer. We are told to try and come up with a solution that is less than O of n square complexity. Okay, so let's get to the board and see how we can come with this. So we are given something like 2, 7, 11, and 15, and we are told the target is 9, and we are trying to find the two numbers that we sum up to give us our value, which is 9. So one approach we could use, which is not optimal, is brute force to have a for loop. For example, we go through every item starting from 2 all the way to 15. We go through each item one after the other, and once we are on each of the item, we go through from the next item. So for example, 7, 11, and 15, and check if any of them will sum up with 2 to give us the sum. So in this situation, by the time we start, we will sum up 2, and then in the first loop, in the inner loop, it will go to 7, 11, and 15. So when it checks 2 plus 7, it sees that it's 9. So we know that it is these two indexes. But that will be a O of n square approach. But I feel we could do better than that, because if we have a dictionary, for example, if we make use of a dictionary and we store all the values. So for example, we store that 2 exists in index 1, something like that. Well, this will not, because if I have multiple numbers, so it will not work, because 2 will have existed, so that might not be it. So but what we could now do is we could say 2 at index. Okay, so what if what we now did was we kept track of the number and the index where we saw it. So for example, we see 2 and 2 was at index 1. So for example, if we have, so let's just go like this and say we are starting with our array, and then we have our dictionary, which is empty initially, has no data inside. So when we get to 2, we ask, does 2 exist in this dictionary? And since 2 doesn't exist, nothing really exists there. So we come here and we put the difference between, so we have a target which is 9. We put the difference between the target, which is 9, from 2. So that is going to be 9 minus 2, that is 7. So 7 and that was at index 0. So this is the first iteration. When we get to the next number, which is 7, we ask, does 7 exist here? 7 does really exist here. So 7, since 7 does exist, we know that there must have been a number that will subtract from 9, which is the target, that will have given us a 7. So we know that since 7 exists, it means that if we check that index, if we check the value of 7 in this dictionary, which is index 0, that will be the index of the initial one, and then the index of where I am now, which is index 1, will be the answer. So let's go with something that will be, let's imagine our target was 17. So let's imagine the target was 17. So in that case, we won't, in the second iteration, sorry, that will have meant, okay, so at the initial state we had an empty dictionary, so 2, so will be 2 minus 17, 17 minus 2, that will be 15. So it will become 15 at index 0. We go to 7. Does 7 exist here? No, 7 doesn't exist. 17 minus 7, does it exist here? 10. 10 doesn't exist, so we put 10 at index 1. We go to the next number, 11. Does 11 exist here? No, 11 does not exist here, so we know that 17 minus 11, that is 6 at index 2. And then finally we go to 15. Does 15 exist here? Yes, 15 exists, so we know that that is where the index of the number that will sum up with where I currently am will be. So 15 is this index, which is index 3, and the initial index was 0, so it's going to be, what I will return will be 0, 3. This will be the array of what I'll be returning, basically. So this is an approach we could go by to solve this algorithm. So let's just get to it, and let's see how we can go with this. Okay, so I said that one approach was that we could say have a for loop, although I'm not sure of the time complexity. So we could say for each norm, okay, so let me use something, because 0 length I plus plus, and in j equals to, okay, so it's going to be I plus 1, the next index, less than norms dot length j plus plus, and then we could just have it to say if norms at index I plus norms at index j, if we have a place that sums up to be target, then we know that we are just to return that. So it's just going to be an array, and then we know the index is index I and index j, basically. So I could even do away with this bracket, since it is just one item there, and I could basically just come here and return an empty one. But we know that we have been guaranteed that there will always be a value, so I could just give it 0. And if we run this, I don't think there should be any issue. It should run, but I will not run this against a larger test case. Or let's go ahead and do that. Although I believe it will fail for some, because imagine if we have 10,000 items, so you need to go 10,000 by 10,000. So let's see. I believe it will most likely fail because of the time complexity. Okay, it did pass, but that is not an optimal approach. And we've been even told that we should try and solve it in O of n squared. So we'll go with a different approach, we using the dictionary. So let's just have a store, let's call it new dictionary, int and int, and so we'll just go through each of the number in norms, and basically we're just checking if the store, if it contains the key, then it means it already exists. So at this point we know we just return an array of store norm and the current. Oh, so I need the current index, so I think I need to use something like, because I need to keep track of the I equals to 0, I less than norms dot length I plus plus, and so this will be norms at index I, and this will be norms at index I, so that I now know that I am at index I. And so that's, so if not, if it doesn't contain, so I just know that I just need to do store dot add, and that will be my target minus norms at index I and the index. So this should suffice. So let me just comment this out, so that, so this should suffice, and if we run this, I think we should be fine basically. But with this now, we just needed a single for loop to achieve the same solution without having to be bogged down with double for loops, which will result in an O of n square algorithm. So let's submit and let's see. So okay, we are adding it. So here it's an item with the same key already exists. So for example, in this particular number, 1 already exists but will not. So, oh, okay, so else, let's say else if store dot contains key. So if it doesn't contain the key, we do not want. So if it doesn't want to contain the key, that's when we want to add it. Or if it contains it, so this should fix that. And let's see. Okay, did I get the logic right? So if the store doesn't contain this, oh, sorry, what we're trying to add is target minus, that's what we're adding to the dictionary, so that's what I need to check for. So else if it doesn't contain this, then go ahead and do that. So let me just do this. Let me check it here before I go ahead to submit again, just to be sure that okay, so that fixes it. And if we submit, should, yes, it does pass. And that's basically how we can solve this algorithm in an O of n time complexity. So I do hope this was clear. I hope we had a good understanding of how this goes and what approach we're able to use to solve this algorithm. Thank you, and I'll see us again in the next video.